In today's video, we'll be looking at how to solve and transpose equations. Now, all the questions that we'll be looking at today were all retrieved from the most recent CXC past papers, so you want to stick around for that. If you're new to this channel, please don't forget to like this video and hit that subscribe button and the notification bell to be notified whenever we post new videos. Alright guys, so these are the questions that we'll be looking at today, alright? As always, we'll be starting from the January 2017 paper, so we'll be going from old to new, alright? So we'll be working our way right up to the January 21 paper, alright? So we'll be looking at all the questions related to solving or transposing equations or formula that was given on the most recent CXC past papers. And as always, what you guys can do is to pause the video, attempt the questions, and then resume the video and watch and see the correct solutions and detailed explanation for each problem. Alright, so as mentioned before, we'll be starting with this question right here, the January 2017 paper. So the formula for the volume of a cylinder is given as V is equal to pi r squared h. Alright, and they ask us to make r the subject of the formula. What that simply means is that we need the r on one side of the equal sign by itself, alright? And if you're not good with transposing equations, you need to check out that video that I have in the description section below titled Easiest Way to Solve Equations, alright? So in that video, I actually taught the topic of transposition that will give you a detailed explanation and give you a better understanding of how to treat with different types of equations, alright? So you want to check that out. Now let's get right back to this question right here. So they want us to make r the subject, and as explained before, that simply means we need the r on one side of the equal sign by itself, alright? And what you would have known, especially if you have checked out that video, alright, whenever you want to get rid of something, you simply do the opposite of the operation that is taking place, alright? So here we have v is equal to pi r squared h. Now what we want to get rid of is the pi and the h, alright? Because we need the r on one side of the equal sign by itself. So being that the pi is multiplying the r, likewise the h, we can divide this side by pi h. And whatever we do to one side, we are required to do the same thing to the other side. So we also have to divide over here by pi h to keep the equation balanced, alright? So what we can do now is to use this pi to cancel pi up here, use the h right here to cancel the h right there, and we'll be left with v over pi h is equal to r squared. Alright, what can we do next? Now we actually want r on one side of the equal sign, not r squared. So we need to get rid of this squared right here. So what we can do now to get rid of the square is to do the opposite of square, which is square root. Alright, and as mentioned before, whatever you do to one side, you are required to do the same thing to the other side to keep the equation balanced. So we have to square root over here as well. So the square root sign will cancel the square sign right there. And we'll be left with r is equal to the square root of v over pi h. Alright, and that's pretty much how you treat with a question like this one, alright? Now let us look at the June 2017 paper. Alright, so this was given on the June 2017 paper. So a formula is given as d is equal to the square root of 4h over 5, and they ask us to determine the value of d when h is equal to 29. Give your answer correct to 3 significant figures, alright? So we have to bear that in mind. And as you can see, this is just part 1 of the question, alright? So there's a part 2 to this question that we'll look at as soon as we complete part 1, alright? So what we're going to do now, we can recall the formula that we were given, which is d is equal to the square root of 4h over 5. And remember, they want us to do what? Determine the value of d when h is equal to 29, all right? So wherever we have h, we are going to replace the h with the value of h, which is 29, all right? And we'll keep this thing over 5, all right? So we'll have what? So d is equal to, what's 4 times 29? All right, so that value we're going to place here, which is 116 over 5. All right, so we'll end up with d is equal to the square root of 116 divided by 5, and 116 divided by 5 will give us 23.2. All right, and now all we need to do is to obtain or find the square root of 23.2, which is 4.85. All right, so that would have been our answer. And of course, I believe when you put this in your calculator, you would have obtained 4.847, and it continues. All right, but we need to round this thing off to 2 decimal place. That way we can obtain 3 significant figures. All right, so this is our answer to 3 significant figures. All right, so that's how you treat with a question like this one. All right. All right, so this is part 2. So they ask us to make h the subject of the formula d is equal to the square root of 4h over 5, all right, which is the same formula that was given in part 1. All right, so what we are going to do now is to make h a subject. That simply means we need h on one side of the equal sign by itself. All right, so what we want to do first is to get rid of this big square root sign right here. All right, so we have d is equal to the square root of 4h over 5. And what we can do now to get rid of this square root sign, we are required to square. All right, and if we square this side, we have to square this side as well to keep the equation balanced. So the square root sign will cancel the square sign, and we'll be left with 4h over 5 is equal to d squared. What we can now do is to put this d squared over 1 and cross multiply. All right, so we'll end up with 1 times 4h, which is 4h, is equal to 5 times d squared, which is 5d squared. All right, and what we can now do is to simply divide both sides by 4. So to get rid of this 4 right here, being that the 4 is multiplying the h, we're going to do the opposite of the multiplication operation, which is division. And what we are required to do now is to divide this side by 4. And if we divide this side by 4, we are also required to divide this side by 4 as well to keep the equation balanced. So this 4 will cancel the 4 right there, and we'll be left with h is equal to 5d squared over 4. All right, so that's how you would treat with a question like this one. All right, so that's pretty much it for the June 2017 paper. Now let us look at the... All right, so this is a question that was given on the June 2018 paper. So they asked us to solve the equation, which is 3 over 2 times y is equal to 12. All right, and what we can first do, this is the same thing as saying, I can rewrite this equation. This is the same thing as saying 3y over 2 is equal to 12. All right, so that's pretty much how we can treat with this thing. What we can always do is to put the 12 over 1 and cross multiply. All right, so 3y times 1 will give us 3y, and this is equal to 2 times 12, which is 24. All right, and what we can do now is to simply do the opposite of what this 3 is doing to the y. All right, so this is the same thing as saying 3 times y. If we want to get rid of the 3, we need to simply do the opposite of the operation of multiplication, which is to divide by 3. And if we divide that side by 3, we are required to do the same thing over here. All right, so 3 will cancel the 3 here, and y will be equal to 24 divided by 3, which is 8. All right, so that's pretty much how you treat with a question like this one. All right, so now let us look at the January 2019 paper. Alright, so this was a question that was given on the January 2019 paper, alright? So they asked us to make x the subject of the formula, and the formula given was what? Y is equal to x over 3 plus 3p, alright? And there are several ways how we can treat with a question like this one, but I'm going to take the method that I believe is the easiest way to treat with a question like this, alright? So here we have y is equal to x over 3 plus 3p. Alright, so the first thing that we want to do is to get rid of this 3p right here. And as always, to get rid of anything, we need to do the opposite of the operation that is taking place. Alright, so what is the opposite of a positive 3p? Opposite of that would have been what? Minus 3p. And if we minus 3p on that side, we are required to do the same thing on this side. Alright, so 3p minus 3p, those things will cancel out each other and we'll be left with y minus 3p on this side is equal to x over 3. Alright, and what we can do now is to put this thing in bracket. Alright, and you'll see why I do that. And then we can put the bracket over 1 and cross multiply. So we'll end up with 1 times x, which is x, is equal to 3 times the bracket. Alright, so 3 times this entire bracket right here, which is y minus 3p. Alright, so that's pretty much how you treat with a question like this one. And it's pretty much solved because all they wanted us to do is to make x the subject. So we just needed to get x on one side of the equal sign by itself. Alright, so now let us look at the June 2019 paper. Alright, so this was a question that was given on the June 2019 paper, and they asked us to solve the equation 3 over 7x minus 1 plus 1 over x is equal to 0, alright? And what we can do here to obtain common denominators, so that's what we want to do. The whole goal when adding fraction is to obtain common denominators so that we can add the numerators. So what we can do, if we have x over here in this denominator, we can multiply over here by x over x. Alright, so we'll have x over x times this fraction here, which is 3 over 7x minus 1. Alright, plus 1 over x. And if we have 7x minus 1 in this denominator, we are going to multiply the 1 over x by 7x minus 1 over 7x minus 1, which I'll keep in bracket. Alright. So what we can do now is to multiply 3 times x, that will give us 3x, alright, over x times the bracket, so x times 7x minus 1 in bracket, alright, plus 1 times anything remain the thing, so 1 times the bracket, I'll have the bracket here, which is 7x minus 1, over x times the bracket, so I'll have x times 7x minus 1 in bracket. Alright, and remember, we should equate this thing to 0. Can't forget about that. Alright, that's very important. So what we're going to do now is to actually add the numerators, alright? Because what you would have observed is that now we have common denominators, alright? So we can simply add the numerators. So we'll have 3x plus 7x. That will give us 10x, and we'll have the minus 1 there. And we'll put all of this over our common denominator, which is x times 7x minus 1 in bracket. Alright, and remember all of this is equated to 0. Alright, so what are we going to do now? We can simply put 0 over 1 and cross multiply. Alright, so what we want to do now, I'm going to keep this in bracket, being that this is a binomial expression. So I want to keep that in bracket. So 1 times that will give me the same thing. 1 times anything, don't change the value of the thing. Alright, and 0 times anything is 0. So 0 times x times 7x minus 1 in bracket will give me a 0. Alright, so what I'm required to do now is to simply solve this thing, alright? So I can transpose this thing. So what I want to do, I want to get rid of this negative 1 first. To get rid of negative 1, I need to do the opposite of negative 1, which is to add 1. And if I add 1 on this side, I'm required to do the same thing on that side as well. So negative 1 plus 1, those things will cancel out. And I'll be left with 10x is equal to 1. what I'm going to do now is to divide both sides by 10, all right? Because here we have 10 times x. So I want to do the opposite of that operation, which is to divide, all right? And if I divide over here by 10, I'm required to divide over here by 10 as well. So 10 cancel 10, and x is equal to 1 over 10, all right? And that's pretty much how we treat with a scenario like this one, all right? So this would have been the solution for the question that was given on the June 2019 paper, all right? Now let us look at the January 2020 paper. So this is part 1 of the question that was given, all right? And in this part, they ask us to solve the equation r plus 3 is equal to 3 times r minus 5 in bracket, all right? So what we are required to do first is to expand this bracket over here. So here we have r plus 3 is equal to, and to expand this bracket, we are required to integrate the whole concept of the distributive law, all right? So we'll have 3 times r, which is 3r. Then we'll have 3 times negative 5, which is negative 15. All right, so what I'm going to do now, I'm going to group the numbers together on the left-hand side and the letters together on the right-hand side, all right? So here we have r, and to get rid of this r over here, I'm going to minus r, all right? And remember the plus 3 here, all right, is equal to 3r. And remember, if we minus r over here, we're required to minus r over here as well. And we still have the minus 15, all right? So I won't move that as it. R minus r, those two r will cancel out each other, and I'll be left with 3 over here is equal to 3r minus r will leave us with 2r minus 15, all right? Now what we want to do is to get rid of the negative 15 now. So to get rid of this negative 15, I'm going to do the opposite, which is to add 15. However, if I add 15 on this side, I'm also required to add 15 on this side as well. So negative 15 will cancel the positive 15. And over here, I'll have 3 plus 15, which is 18, is equal to 2r, all right? Now, what I'm going to do now is to get rid of this 2 right here. But first, I want to know what is this 2 doing to the r, all right? So this 2 is actually multiplying the r. So we are required to do the opposite of that operation, which is division. So I'm going to divide this side by 2. And if I do so on this side, I'm also required to divide this side by 2 as well. All right, so 2 will cancel 2 over here. And I'll have r being equal to 18 divided by 2, which is 9. All right. So that's pretty much how you treat with the first part of the solving equation question that was given on the January 2020 paper. All right, now let us look at part 2. All right, so here we have part 2 of the question that was given on the January 2020 paper. All right, and here they ask us to make k the subject of the formula 2a is equal to pi times k squared plus 3t. All right, so what we can do now, the first move we are going to make is to actually get rid of this positive 3t right here. So we have 2a is equal to pi k squared plus 3t. So to get rid of this positive 3t right here, I'm required to do the opposite of that, which is to minus 3t. And if I minus 3t on this side, I'm also required to minus 3t on the left-hand side as well. All right, so 3t minus 3t, those things will cancel out. And I'll be left with 2a minus 3t is equal to pi k squared, all right? So what we can do now is to get rid of this pi, all right? So what the pi is doing to the k, it's multiplying the k squared, all right? So what we're going to do is to do the opposite of that, which is to divide by pi, all right? And if I divide this side by pi, I'm also required to divide over here by pi as well. So pi will cancel pi right here, and I'll be left with 2a minus 3t over pi, all right, is equal to k squared. Now, the next thing I'm going to do is to get rid of the square right here. So they ask us to make k the subject and not k squared, all right? So in order to get rid of the square, I'm required to square root. And if I square root this side, I'm also required to square root this side as well. So the square root sign will cancel the square, and I'll be left with k is equal to the square root of 2a minus 3t over pi. Alright, and that's pretty much how you treat with a question like this one. Alright, so that's it for the questions that was given on the January 2020 paper. Now let us look at the final paper, which is the January 2021 paper. Alright, so here we have the January 2021 paper, alright? And we actually have two parts, two separate questions to treat within this paper that relates to the whole solving equation or transposing equation concept, alright? So we want to look at part 1 first, which asks us to solve the equation x over 1 minus x minus 4x is equal to 0. Alright, so what we can do first is to put this 4x over 1, alright? Now what I'm going to do now to obtain common denominators, if I have 1 in this denominator over here, I'm going to multiply this fraction over here by 1 over 1. And being that I have 1 minus x in this denominator over here, I'm going to multiply this fraction by 1 minus x over 1 minus x, alright? So let's do that. So I have 1 over 1 times x over 1 minus x, and I'm going to keep the binomial expression in bracket, minus 4x over 1 times, again, I'm going to multiply this fraction by 1 minus x over 1 minus x, alright? And I'm going to keep that again in bracket. So 1 minus x over 1 minus x, alright? And remember, this is equated to 0. Alright, so what we are going to do now is to clean up this thing a little bit. So I'll have 1 times x, which is x. 1 times 1 minus x, which is 1 minus x. So 1 times anything, remain the thing. And here now I'm required to integrate the whole concept of the distributive law. So negative 4x times 1, that will give me negative 4x. And negative 4x times negative x, that will give me a positive 4x squared. Alright, over 1 times 1 minus x in bracket, which will remain 1 minus x, alright? And this is equal to 0. Now what I can do, if you would have observed, now we have obtained common denominators, alright? So what we can do, we can put the numerators, we can combine the numerators and put it over the common denominator. So we can have x minus 4x plus 4x squared over 1 minus x is equal to 0. Alright, now what we can do next is to simplify this thing a little bit. So x minus 4x, that will give us a negative 3x plus 4x squared over 1 minus x is equal to 0. Alright, now what we can also do next is to put this 0 over 1 and cross multiply. Alright, so we can have 1 times this thing up here and 1 times anything, remain the thing. So I'll be left with negative 3x plus 4x squared is equal to 0 times anything is 0. Now what I'm going to do here, I'm going to factor out what's common between these two terms, alright? And that would have been x. So I can factor out x here and I'll be left with negative 3 plus 4x is equal to 0. Alright, now what I can do next is to equate the outside term to 0. So x is equal to 0. And I can also equate the bracket to 0. So negative 3 plus 4x is also equal to 0. Alright, so one of the values of x would have been 0. Now we can transpose this thing for x to obtain the other value. Alright, so first thing we want to get rid of is this negative 3 right here. To get rid of negative 3, I'm required to do the opposite of a minus 3, which is to add 3. Alright, and remember I still have the plus 4x here is equal to 0. Remember, if I add 3 on this side, I'm required to do the same thing on the other side to keep the equation balanced. So I have to add 3 over here as well. So negative 3 will cancel 3 right there. And I'll be left with 4x is equal to 3. Alright, what I'm going to do now is to divide both sides by 4. Alright, to get rid of this 4 right here. So I'll have 4x divided by 4 over 3 over 4 right here. So 4 cancel 4, and I'll be left with x is equal to 3 over 4. Alright, so I can say therefore x is equal to 0 and x is also equal to 3 over 4. Alright, so this would have been my solution, alright, to the problem. Alright, so that's pretty much how you treat with a question like this one. Alright, so here we have part 2 of the question that was given on the January 2021 paper and the final question that we'll be looking at in this video. Alright, so in this question they ask us to make v the subject of the formula p is equal to the square root of 5 plus vt. Alright, so what we're going to do first, we're going to rewrite the equation. Alright, and what we're going to do next, the first thing we want to get rid of is the square root sign right here. Alright, so in order to get rid of the square root sign, we're required to square this thing. And if we square this side, we're required to square over here as well. Alright, so the square root sign will cancel the square right here. And I'm left with p squared is equal to 5 plus vt. So the next thing that we want to get rid of is this 5 right here, because remember they asked us to make v the subject of the formula. Alright, so we want to get v on one side of the equal sign by itself. So we want to get rid of this 5 next. So to do so, being that here we have a positive 5, we need to do the opposite of that, which is to minus 5. If we minus 5 on this side, we also are required to minus 5 over here as well. And remember, we had a plus vt over here. Alright, so 5 minus 5, these things pretty much cancel out each other. And I'm left with p squared minus 5 is equal to vt. Now, remember, we want to make v the subject, so we need to get rid of the t. Vt is the same thing as v times t, so it's multiplication taking place here. So to get rid of the t, I need to do the opposite of the operation of multiplication, which is division. So I'm going to divide over here by t. And if I divide over here by t, I'm also required to do the same thing over here as well to keep the equation balanced. So t will cancel t right here, and I'll obtain the solution of v is equal to p squared minus 5 over t. Alright, so this would be our solution. And that's pretty much how you treat with solving equations and transposing formulas and equations as it relates to CXC. Alright, so this is where we'll be ending today's video, guys. If you watch this video to the end, don't forget to give this video a thumbs up, and if you haven't yet done it, please subscribe to the channel and hit that notification bell to be notified whenever we post new videos.